Hello and welcome to our next video on critical regions. In this video we will look at how to find critical regions for two-tailed test. And the best way how to start is by looking at some example. So you can pause the video, read the question, and then we'll start doing it together. So in this question we are checking at the 5% significance level whether the probability of a customer buying an iPhone has changed. So as how do we know it's a two-tailed test? Because here it says it has changed. It doesn't say is it bigger than 0.2, is it smaller than 0.2. It's just asking us to check whether it has changed. That's why it's a two-tailed test. So H0 is P equals 0.2 and H1 is P is different from 0.2. And in the second step, as usual, we have to find the critical region using tables. So we have to look at both tails. We have to find the critical region for the left tail, which is here, and critical region for the right tail, which is here. So for the left tail, once we've halved the significance level, which now it's 2.5%, if we have 5%, we can see that these probabilities are all smaller than 2.5%. This is already too big, this is 2.8%. So the critical region for the left tail is this region here, all the x's less than or equal to 2. For the right tail, we first have to find the first value, which is more than 97.5%, because this is 100% minus 2.5. We are looking for the last 2.5% of the distribution. So the first value above 97.5 is the one in the blue box, which corresponds to x equals 13. But as we know, this is not the critical value. The critical value is 14. And so the critical region starts from 14, and it's from 14 down, all the x's less than or more than or equal to 14. The actual significance level of the left tail test, as we can see here, is of the left tail is 0.0079. The right tail is 1 minus 0.9921, which is surprisingly the same, 0.0079. And so the actual significance level for the test, for the whole test, is 0.0158. And so finally looking at step 3, because 11 people bought an iPhone, and this is not in a critical region, because it starts from 14, so we cannot reject H0, and so in this case we have to reject H1. And in the context, it means that the H1 was wrong, and the manager's claim is not correct, and the probability of customers buying an iPhone has not changed. So in this question, it's the next question. You can pause the video and try to do it on your own. You can use the tables, which I've already done the table here for you. You need to do all 3 steps, find H0 and H1, find both critical regions for both tails, and then decide what is the conclusion of the test. So hopefully you've done it, and so now we can just check the answers. So H0 was P equals 0.15, and H1 was P is different from 0.15. In this question we are checking whether the proportion of patients who suffered some complications after heart surgery has changed from the national average, which was 15%, using 10% significance level. So this was the national average. Has it changed from 15%? Now, if we have 10% significance level, we are checking 5% at each tail. So for the left tail, we've got all the x's less than or equal to 3, because they are all smaller than 5%. So this is the left tail critical region. The actual significance level of this region is 0.046. The critical region for the right tail, which is which are the probabilities here, is start from 13. So all the x's more than or equal to 13, and the actual significance level is 0.0132. So the total significance level for this test is 0.0592. And the 2 people suffered complications, which this is in a critical region. Yes, so we can reject H0 and accept H1. So the hospital's claim is correct, and the proportion of patients who suffered complications is different from the national average. And that's the end of this video. Thank you for watching.